Welcome back to Physics for KSSM. Let's continue the gas law topic, the last part, that is Gay-Lussacs Law. Okay, look at the diagram here. Measure pressure of air in car tire before and after a long journey. So we use a pressure meter. So before journey recorded here is 210 kilopascal. After the long journey recorded as 220 kilopascal. So you can see there's increase in pressure. So in this case, the size of tire is constant, meaning the volume of air inside the tire is constant. So now what exactly caused the change in the pressure? So the change in the pressure is caused by temperature. When the tire is used for a long journey, it becomes hot. So the air inside will receive heat energy or average kinetic energy increase. Thus temperature of the air increase. Okay, so we will discuss further on this topic. So relationship between pressure and temperature at constant volume of gas is known as Gay-Lussacs Law, or last time we discussed as pressure law. So explain Gay-Lussacs Law using kinetic theory of gases. Okay, look at the figure here. We have a container with a fixed mass of gas heated at a constant volume. When the temperature of the gas increases, so we heated it up, so temperature increases, so the average kinetic energy of its molecule increases. So the molecule moves with higher velocity. So you can see the arrow here, the short one low velocity, the longer one is high velocity. So meaning here, the molecule moves at higher velocity. As the volume of gas does not change, the rate of collision of gas molecule with the wall of container increases. Force per unit area on the wall of container also increases. As such, gas pressure increases. So in this case, the container cannot change its volume. Okay, so if the volume is constant, when the temperature increases, so what happened to the pressure? The pressure will increase. Okay, now you can refer to your textbook, experiment 4.6. So this experiment is to relate between temperature of gas and pressure of the gas. So hypothesis, the higher the temperature, the higher the gas pressure. Aim to determine relationship between temperature and pressure for a fixed mass of gas at constant volume. Variable, we have manipulated variable, temperature theta. We have responding variable, pressure P, constant variable, volume and mass of air. So in this case, when we discuss three variables, P, V and T, so this law, Gay-Lussacs Law, discuss about temperature and pressure, meaning the volume and mass must be constant. Okay, apparatus and material needed, round bottom flask, okay, large beaker, thermometer, pressure gauge, Bunsen burner, wire gauze, tripod stand, stirrer, retort stand and wooden block, water and ice. You can look at the setup. We have a beaker of water. Okay, here we have a Bunsen burner to supply heat. At the top, at the surface of water, we put an ice to prevent heat loss of surrounding. We use thermometer to measure temperature of water. And then we have a stirrer here to ensure uniform heat throughout the liquid or water. And then we have a round bottom flask filled with air and then closed with a cork and connect with a rubber tube to the pressure gauge. Here is a Bourdon gauge. So why we put the thermometer outside in water? So we assume that when we heated at certain temperature, so the temperature of water is equals to temperature of air inside the round bottom flask, or thermal equilibrium is achieved. Okay, now how we do the experiment? So just follow the procedure given. So the stirrer must always stir the water to ensure heat transferred throughout the water uniformly. Okay, what we do is you heat the water, or initially we set the temperature at 30 degrees Celsius. So we record air pressure and then heated the water until temperature shown by thermometer is 40. Then we record the reading of the pressure gauge. we continue by increasing the temperature by 10 degrees Celsius until 80 degrees Celsius, and we record the pressure. So we have 6 sets of data of temperature and pressure, thus we can plot a graph. Okay, now discussion. What is the advantage of using round bottom flask to heat the air? The thermometer is placed in the large beaker filled with water. What is assumption made so that thermometer reading is the same as temperature of the air in the round bottom flask? Okay, let's look at the answer for number 1. Why we use round bottom flask? The flask is round bottom, so that heat is uniformly distributed throughout on heating. So we can get the air inside will be uniformly heated, okay, when we use the flask which is round shape. Okay, number 2, thermal equilibrium is achieved between water in the beaker and the gas in the round bottom flask. Thus, the reading of the thermometer is equals to gas temperature. This is our assumption. Okay, if we plot a graph of the pressure against temperature in degrees Celsius, you can see the points all distributed this way. So the shape of the line will show that P increases linearly with theta in degrees Celsius. What we do, we extend the line, extrapolate the line until pressure is 0. When pressure is 0 means the molecule becomes static or stationary. So at this point we call it 0 Kelvin or absolute 0 temperature. So that's why here negative 273 degrees Celsius actually is equivalent to 0 Kelvin. Thus, when we plot a graph of P against T in Kelvin, we get a straight line passed through origin. So from here we can say P is directly proportional to absolute temperature. Here is the conclusion based on the graph. So we have a PVT triangle. So for Gay-Lussacs law, volume is constant. So you just cover the volume. So you can see the ratio of P and T is constant. So we have P1 over T1 equals to P2 over T2. So this relationship can be used to solve problem involving pressure law or Gay-Lussacs law. Okay, let's look at the sample of problem. Number 1, the pressure of the gas in the tank is 3.2 atmosphere at 22 degrees Celsius. If the temperature rises to 60 degrees Celsius, what will be the pressure in the tank? So here, no mention about volume, meaning volume is constant. So the relationship between P and T, meaning Gay-Lussacs law. So now we use the name as Gay-Lussacs law. Okay, what we do for the Gay-Lussacs law is just valid with temperature in Kelvin or absolute temperature. So what you do, you must convert temperature to Kelvin. So you can see the 22 degrees Celsius convert to Kelvin, you just plus 273. And then 60 degrees Celsius convert to Kelvin, you also plus with 273. So in the end we get P or the P2 equivalent to 3.61 atmosphere. So do not worry about the unit. If the unit given atmosphere, meaning your answer P is also atmosphere. Okay. Number 2, gas in the closed steel cylinder has a pressure of 180 kilopascal at temperature 25 degrees Celsius. What is the gas pressure when the cylinder is heated to a temperature of 52 degrees Celsius? So same thing. What you do, you just list down all the information given and remember the temperature must be in Kelvin. Okay, so we use the Gay-Lussacs law formula. So P1 over T1 equals to P2 over T2. You substitute all the values in. So you solve it, you get P2 equivalent to 196.3 kilopascal. So it's very simple question here, but you need to do more exercise on this topic so that you can understand better. So that's all for this topic. So meaning that's the end of chapter 4 heat. So do subscribe, like and tap for more oncoming videos. Do support physics teacher.